Hi everyone. Today is the second video of the complete paper solution of 9709 paper 1 variant 1 May June 2018. So let's start. Question number 7. Relative to an origin O, the position vectors of the points A, B and C are given by this and this. Find AC. Okay. So AC will be equal to AO plus OC. It's A from O and then O from C. So this will become AC is equal to AO. We got OA, but we need AO. It means AO is the negative of OA because the direction is opposite. So that's why I will use opposite signs for AO. So the AO will be -1 plus 3 minus 2 plus OC is we'll use as it is, that will be 3 1 minus 2. So AC will be, by adding them, will become 3 minus 1 2, 3 plus 1 4, minus 2 minus 2 minus 4. So 2 minus 4. So this is our answer of AC. Okay. Part 2. Point M is the midpoint of AC. Find the unit vector in the direction of OM. Okay. So for the unit vector in direction of OM, we need to find OM first. For that, we need AM, because M is the midpoint of AC. So AM will be half of AC, means M is in the mid of AC. So half of AC means 1 by 2. What is AC from the previous part? 2 4 minus 4. So this will become 2 over 2, 4 over 2, minus 4 over 2, which is 1 2 minus 2. So this is our AM. Now we need to find OM. So what is OM? It will be OA plus AM. A from A to O, and then O to A and then A to M. So put the values. OA is from the first part 1 minus 3 2, and AM, this is we already found 1 2 minus 2. So this will become by adding 2 minus 1 0. This is our OM vector. So we know that the vector, any vector, is actually equal to the magnitude and the direction, which is represented by the unit vector. Let's suppose this is the unit vector. So therefore bring this OM magnitude on the left side. So this will become our unit vector is equal to OM vector over OM vector's magnitude. So put the values. OM vector is 2 minus 1 0 over OM magnitude is 2 2 square plus minus 1 square plus 0 square, which is equal to 2 minus 1 0 over 4 plus 1, which can be written as 1 over under root 5 2 minus 1 0. This is our answer, unit vector in the direction of y. Part 3. Evaluate AB and AC and hence find the angle BAC. Okay, we already have AC in the part 1. Now we'll have to find AB and then we'll move further. So how we can find AB? The AB can be written as A from O and then O from B. This will be the root of AB. So put the values. AO, again the negative of OA from part 1, minus 1 3 minus 2 plus OB, the from part 1 again, minus 1 3 5. So by adding them we'll get minus 2 6 and 3. This is our AB. Okay, now we know that the dot product of two vectors, the dot product of AB and AC is the unit vector of AB, unit vector of AC, cos angle between them. Okay, so cos BAC is equal to AB. Bring these two on the left side. So sorry, this will not be the magnitude because these are simple vectors. Dot AC over AB magnitude AC magnitude. Okay, now put the values. What is AB? This is minus 263. This is AB. AC from the previous part, it is 2 4 minus 4 over magnitude of AB is minus 2 square plus 6 square plus 3 square, and magnitude of AC will be 2 square plus 4 square plus minus 4 square equals, so what will be the product of this? This will be minus 2 multiplied 2 minus 4, 6 multiplied 4 24, 3 multiplied minus 4 minus 12 over 4 plus 36 plus 9, 4 plus 16 plus 16. So this will be equal to this will be 4 8 over, this will be 49 square root into 36 square root. So this will be equal to 8 over 49 square root is 7, 36 square root is 6. So 2 3s are, 2 4s are, so 4 by 21. So actually this is cos BAC is equal to 4 by 21. So angle BAC is equal to cos inverse 4 by 21, and this will be BAC is equal to cos inverse 4 by 21 is 79 degrees. So this is our answer. Question 8. A geometric progression has a second term of 12. The second term of geometric progression is represented by AR, which is 12, and sum to infinity is 54, means sum to infinity is 54. Find the possible values of the first term of the progression. So we need to find A, the first term of the progression. So since AR is 1 over 12, therefore R can be written as 12 over A. Okay. Now we are given with we know that the S infinity is actually A over 1 minus R. This is the formula for the sum to infinity. So it is already given, which is 54. I'll write it as 54 is equal to A over 1 minus R's value is 12 over A. Okay, so 54 is equal to A over, take the LCM, again A, this will become A minus 12. So take this, A will go upside, it will be 54 is equal to A square over A minus 12. Okay, so by cross multiplying, this will become A square is equal to 54A minus 648 is equal to 0. Okay, so take these two things on the left, it will become A square minus 54A plus 648 is equal to 0. So solving them by Metron break method, it will become A square minus 36A minus 18A plus 648 is equal to 0. So take A common, it will become A minus 36. Take 18 common, it will become A minus 36 is equal to 0. So take A minus 36 again common, it will become A minus 18 is equal to 0. So the both will be equal to 0. A minus 36 is equal to 0. A minus 18 is equal to 0. So A is equal to 36. A is equal to 18. So these are our answers. Part nth term of a progression is P plus Qn, where P and Q are constants, and Sn is the sum of the first 10 terms. Find an expression in terms of PQ and N for Sn. Okay, this is our nth term. So nth term means last term, that is P plus Qn. So if this is the last term, so it means first term will be, we'll put n is equal to 1, so we'll get the first term. So the first term will be L1, which is p plus q, because n is 1. This is the first term. Now we know the formula for sum of n terms, that is Sn is equal to n over 2 into 2a plus n minus 1 d. So this formula can also be written as a plus last term, because this can be written as a plus n minus 1 d. So a plus n minus 1 d is the last term. So put the values. N over 2, a is the first term. The first term is p plus q, and this is the last term. Last term is p plus qn. So this will become n over 2, 2p plus q plus qn. This is expression of Sn in terms of p, q and n. This is our answer. Okay. Part 3. S4 is 40 and S6 is 72. Find the values of P and Q. Okay. So we know that Sn is this. So for S4 we'll put n is equal to 4. So this will become S4 is equal to 4 over 2, 2p plus q plus 4q, because we are putting n is equal to 4. So 4q. So the value of S4 is 40. So we'll put the value of S4 here. 40 is equal to, this will become 2 times 2. So 2p plus 4p, this is 2p plus q plus 4q, which is 5q. So 2p plus 5q. Take 2 on this side. So this will the final term will become 2p plus 5q is equal to 20. This is equation number 1. Now again, S6 is 72. So for S6 we'll put n is equal to 6 here in the nth term. This will become S6 is equal to 6 by 2, 2p plus q plus nq means 6q. So this will be 3, and the value of S6 is 72. So this will be equal to 72 is equal to 3 into 2p plus 7q. So take 3 on this side. So this will become 2p plus 7q is equal to 72 over 3, which will be 2p plus 7q is equal to 24. This will be 24. This is equation number 2. Now I got 2 equations, so I'll solve them simultaneously for p and q. So I'll have to use this space. So I got 2 equations. Number 1 is 2p plus 5q is equal to 20. The second is 2p plus 7q is 24. 2p plus 7q is 24. So change of signs. This will be cancelled. Will become minus 2q is equal to minus 4. So q is equal to 2. This is the value of q. I'll put this value of q in first equation from equation 1. So this will be 2p plus 5 into 2 is equal to 20. So 2p plus 10 is equal to 20. 2p is equal to 20 minus 10. 2, P is equal to 10, so P is equal to 5. This is the second value. So this is our answer. Question number 9. There are two functions f and g. This is function f, this is the function g. Find the point of intersection of the graphs y is equal to fx and y is equal to gx. Okay. So y is equal to fx means y is equal to the function of fx is 1 by 2 x minus 2. Okay. This is equation 1. Y is equal to gx, this is the second equation. So y is equal to gx means 4 plus x minus 1 by 2 x square. This is equation number 2. Okay. Now because we need to find the point of intersection, it means we need to solve these two equations. So put the value of y here from this equation. So putting value of y from 1 in 2. So this will become 1 by 2 x minus 2 is equal to 4 plus x minus 1 by 2 x square. Now we'll solve them. Take LCM of both sides. This will be 2, so it will be x minus 2x is equal to, this LCM will be 2 again, it will be 8 plus 2x minus x square. Okay. So these two will be cancelled because by the cross multiplication we'll get the final equation x minus 2x is equal to 8 plus 2x minus x square. So bring all these right hand side elements to the left. X minus 2x minus 8 minus 2x plus x square is equal to 0. Okay. Now by solving, it will become x square minus x minus 12 is equal to 0. Okay. Now by solving by Metron break method, it will be x square minus 4x plus 3x minus 12 is equal to 0. So take x common, x minus 4 plus 3 common, x minus 4 is equal to 0. So x minus 4 common, x plus 3 is equal to 0. So this will become x minus 4 is equal to 0, x plus 3 is equal to 0. So x is equal to 4, x is equal to minus 3. Now for these two values of x, we need to find the values of y. So from 1, y is equal to half x minus 2 means half 4 minus 2. So y is equal to 2 minus 2, which is 0. So from here as well, from 1, y is equal to 1 by 2 minus 3 minus 2. So this will become y is equal to minus 3 by 2 minus 2. So after taking LCM, it will be minus 7 over 2. So therefore there will be two points of intersection, 4, 0 and minus 3 minus 7 over 2. So these are the 2 points of intersection. Okay. Part 2. Find the set of values of x for which fx is greater than gx. Okay. fx is greater than gx means fx is 1 by 2 x minus 2 is greater than gx means 4 plus x minus 1 by 2 x square. So take everything on the left side, it will become 1 by 2 x minus 2 minus 4 minus x plus 1 by 2 x square is greater than 0. So by solving it will become 1 by 2 x square. This will be 1 by 2x minus x will be 1 minus 1 by 2x minus 6 is greater than 0. So take LCM, it will be 2, that will be x square minus x minus 12 is greater than 0. So this will become x square minus x minus 12 greater than 0. So by Metron break method, it will be x square minus 4x plus 3x minus 12 greater than 0. So x common x minus 4 plus 3 common x minus 4 is greater than 0. So take x minus 4 common, it will become x minus 4 into x plus 3 is greater than 0. So it will be x minus 4 greater than 0, x plus 3 greater than 0. So x is greater than 4, x is greater than minus 3. So now, for the moment we'll consider them equal to 0 for the critical values. So this one is critical equal to 4, this one is equal to minus 3. So now I'll make a parabola here like this. This is 4, this is minus 3. Now this is actually a cup shaped parabola because x square is positive. So this parabola will open upwards. So this greater than 0 means the area above the x-axis is our answer. This is our answer region. So this is our answer and this is our. Therefore, x is greater than 4 and x is less than minus 3. This is our answer. Part 3. Find an expression for f g x and deduce the range of f g. Okay. So f g x means f of gx means we need to replace x by gx in fx. So this will become f of gx is equal to 1 by 2 because fx is 1 by 2x minus 2. So it will be 1 by 2 g of x minus 2 because we'll replace x by gx. Now gx also has its own value. What is the gx value? From part 1, it's 4 plus x minus 1 by 2 x square minus 2. So this will be after solving 4 by 2 x by 2 minus x square over 4 minus 2. So after taking LCM 4, it will be 8 plus 2x minus x square minus 8. This will be cancelled. So we'll get 2x minus x square over 4. Let's suppose this fgx is y. Okay, for the range, this is our f of gx. So for the range of fg, we need to find the stationary point first. So for stationary we need the derivative of this function, because we need to put the derivative is equal to 0, because the gradient of the curve at stationary point will always be 0, because tangent will be horizontal parallel to the x-axis. So dy by dx is equal to will be 2 minus 2x over 4. Yes. Now put dy by dx is equal to 0, because for the stationary point. So this will be 2 minus 2x over 4 is equal to 0. So by cross multiplying, this 4 will be 0. So 2 minus 2x is equal to 0. 2 is equal to 2x. Therefore, x is equal to 1. It means x is stationary points x coordinate is 1. So I need y value as well. So I'll put x here. So this will be y is equal to 2 into 1 minus 1 square over 4. This will be 2 minus 1 over 4. That is y is 1 over 4. So if we plot a parabola here, just for the understanding, because this got negative value, it means the parabola's opening is in the bottom, like this. So this is y 1 over 4. It means this is the maximum value at x equal to 1. This is x equal to 1. So this is the maximum value. Therefore, all the values will be less than 1 over 4. So range of fg is less than equal to 1 over 4. This is the range. Okay, fourth part. The function h is defined by this. So this is hx 4 plus x plus minus 1 over 2x square. Find the smallest value of k for which h has an inverse. Means we need to find the line of symmetry. So for the line of symmetry, again we need to find the stationary point, and for stationary point we need to find the derivative of this function, and then we'll put equal to 0. So derivative of hx will be h dash x. This will be derivative of 4 is 0, x is 1 minus this will become 1 over 2 into 2x. So this will be cancelled with this. H dash x is equal to 1 minus x. Put h dash x is equal to 0. It means we need stationary value. So 1 minus x is equal to 0. So x is equal to 1. It means this is the line of symmetry. So that's why the smallest value of k will be 1 for h has an inverse. So this is our answer. Question number 10. The curve with equation this y is equal to x cube minus 2x square plus 5x passes through the origin. Show that the curve has no stationary point. Okay, we got the curve y is equal to x cube minus 2x square plus 5x. So for stationary value, everyone knows we need the gradient of this curve, and for gradient we need dy by dx. Therefore by dy by dx will be 3x square minus 4x plus 5. So for stationary value, the gradient of the curve should be 0, because the tangent at that point should be parallel to the x-axis. Therefore, by putting dy by dx is equal to 0 for stationary value. Therefore, 3x square minus 4x plus 5 is equal to 0. Okay. If this curve has a stationary value, then this equation should have some real solution. But we can see we cannot solve this equation by Metron break method. So this means this equation has no real solution. Since no real solution, because if you check, you cannot solve this equation by Metron break method. So that's why, therefore, there is no real solution. Therefore, curve has no turning point. So if the curve has no turning point, means the curve has no stationary value. Therefore, curve has no stationary value, because a curve always have a stationary value when there is a turning. This is shown that curve has no stationary value. Okay, part 2. Describing the gradient of the curve by m, find the stationary value of m by and determine its nature. Okay, the gradient is 3x square minus 4x plus 5, so we'll denote it by m. So m is equal to 3x square minus 4x plus 5. So for stationary value, again we need the gradient of this curve, means we need to find the derivative of this. So dm by dx is equal to 6x minus 4. So for stationary value, dm by dx should be equal to 0, as I discussed earlier, that the gradient of the curve at stationary value should be 0. Therefore, 6x minus 4 is equal to 0. So 6x is equal to 4. This will become x is equal to 4 by 6, or x is equal to 2 by 3. So this is the value of x. But I need the stationary value of m, means I need the value of m at this point. So I'll put value of x here in the first equation. So m will be 3 into 2 by 3 square minus 4 into 2 by 3 plus 5. So this will be 3 into 4 by 9 minus 4 into 2 by 3 plus 5. So 3 3s are 9. So 4 by 3 minus 8 by 3 plus 5 over 1. Take the LCM 3. So it will be 4 minus 8 plus 15, which is 11 by 3. So this is the stationary value of m. This is our first answer. Now we need to check the nature of this value. We know that dy by dx is 6x minus 4. So for the nature, we need d2y by dx square. So d2y by dx square is 6, which is positive, greater than 0. So if the d2y over dx with double derivative of is positive, then the point is minimum. Therefore, this is minimum point. So that's our answer. Part 3. Showing all necessary working, find the area of the region enclosed by the curve and x-axis and the line x equal to 6. It means uh, there are two values from origin to 6. We need to find area under the curve. So we know the value of y is, the curve's value is x cube minus 2x square plus 5x. So for the area under the graph, the formula is area is equal to from 0 to 6, because the value is from origin to x equal to 6, y dx. This is the formula for area of the curve. So area is equal to 0, 6, that is x cube minus 2x square plus 5x dx. Okay. So we'll take the derivative of this. So x cube derivative is x 4 over 4 minus x square derivative is 2 into x cube over 3 plus 5x square over 2, 0, 6. So put the limits. This will be 6 raised to power 4 over 4 minus 2 into 6 raised to power 3 over 3 plus 5 into 6 raised to power 2 over 2 minus 0, 0, 0. So we'll not put 0 here. So this will become, after solving, 3 to 4 minus, this will become 144 plus 90, and this will be 414 minus 144, which is 270. So this is our answer, area of the curve. So that's it, the end of the paper, question paper 11, paper 1, variant 1, May, June 2018. So thanks for watching, see you in the next video.